All right, AP Stat, let's start these examples. It's going to be fun. Okay, so this is your first example in your Unit 5 notes. All right, so we have AP scores here, and I've given you a discrete probability distribution. I've got AP score outcomes listed at the top, 1, 2, 3, 4, 5, and their matching probabilities. So the first thing I'm going to do is find the expected AP score. So there's a couple of different ways you can go about doing this. You can use your formula and show your substitution here. Well, you don't really have to show your substitution, just the formula itself. And you're going to have the formula chart on the test, so you can just write it that way if you want to. And then, of course, on part B, we're finding variance and standard deviation. So remember, the variance is the standard deviation squared. So it's going to look like this. And I'm going to show you how to do this in Staplet, because that's the easiest way to do it. Okay, so then of course your standard deviation will be right here. Okay, so I'm going to go to Staplet, so staplet.com, where we've been 1,000 times, and I'm going to choose this discrete random variable. So the variable name for this particular situation, AP scores. Okay, and I'm going to put my values in here. So I've got 1, and then 2, and then I'm going to add 1. Oh. I just love it when things work out exactly as I want them to. I'm okay, kids. It's fine. All right, so my probabilities now I'm going to enter in. You know what? I'm going to put the pencil up, and maybe that will make it easier. Okay, so for 1, I've got 0.05. For 2, I've got 0.1. For 3, I've got 0.4. I know you can read and that you already know how to do this, but it's more fun when I narrate. Okay, so begin analysis, life is good. You're always going to get a histogram with these. And then, of course, they show you the mean and standard deviation right under here at summary statistics. So I am going to go back to my notes, and I am just going to fill in this information. So 3.5 is what I got for the mean. And for the standard deviation, I got 1.118. When I square that, I get 1.25 for my variance. So this is my variance right here. This is my standard deviation right here. Okay, so the expected value, of course, you could find by hand. So you could do it this way if you wanted. So your expected value would be 1 times 0.05 plus 2 times 0.1 plus 3 times 0.4. I didn't mean to put a decimal right there. Plus 4 times 0.2 plus 5 times 0.25. And it is totally up to you how you want to do this. If you want to do it by hand, great. If you want to use Staplet, great. If you want to use your graphing calculator, that's great too. All right, so that's example 1. Now let's scroll down here to example 2. Notice right away that example 2 does not give you the table. You have to create the probability model for this. So let's work on this. This is where your skills from the last unit of probability are going to help you. So we have a litter of 7 kittens. 3 are female, that means 4 are male. You're going to pick 2 kittens at random. We're creating a probability model for the number of male kittens. So I'm going to define X. That's going to be my variable, all right? I am going to name it or call it male kittens because my probability distribution model is going to be about male kittens because that's what I was asked to find. So then I've got my probability of X and X here. Well, when I'm choosing 2 kittens at random, I need to think about how many of them can be male kittens. That's what's going to fill up the X row in my distribution. So if I pick 2 kittens, well, they could both be female, which means neither one of them are male. One of the two could be a male, or both of them could be male kittens. So those are the outcomes that are possible here. So now I need to find the probabilities. Well, when I'm talking about 0 male kittens, that means I've got a female and another female. So the probability one of the kittens will be a female, since there are 3 females out of 7, this would be 3 over 7 times 2 over 6, because once you've taken one of the females out, there's one fewer now. So when I multiply this, I get 6 over 42. So that's going to be the probability for 0 male kittens. Okay, now let's look at 1 male kitten. This could happen as a male-female, or the female first and then the male. So we need to take both of these scenarios into account. The probability the first kitten is a male is going to be 4 out of 7, and then the probability the next kitten will be a female will be 3 out of 6. One fewer total kittens, but still all 3 of the females to choose from. So this is going to be 12 over 42. Or I could get a female first, and that's going to be 3 out of 7 times the male second, 4 out of 6, which would be 12 out of 42. So those are the 2 possible ways I could get 1 male kitten, this way or this way. So I've got 24 out of 42. Now the probability of getting 2 male kittens. Well, that's going to be 4 out of 7 times 3 out of 6, which is going to give me 12 out of 42. Rather than finding that probability, you could have just added the 6 and the 24 and then subtracted it from 42 to figure out what that numerator is going to be. So I want you to notice that when I combine all the probabilities in this distribution, they do add to 42 over 42, which is 1, so we're good to go. Now we're going to find the expected number of males and the standard deviation. I'm going to do that exactly the way I did it in the last problem. So I'm going to go to Staplet, if I can manage it. Okay, so I'm going to start over with my discrete random variables. The variable name this time is going to be male kittens. And I can have 0 male kittens, and that probability is going to be 6 out of 42. Or there can be 1 male kitten, and that probability is 24 out of 42. Or I can have 2 male kittens, and that probability is 12 out of 42. Okay, so we're going to begin the analysis here. There's my mean and standard deviation down in the corner. Life is good. Easy peasy, lemon squeezy. All right, so the expected value, and I'm just communicating about this. That's why I'm writing the formula each time, because I'm doing a good job of showing where it's coming from, that I recognize that it's the mean, or the weighted mean, I should say. And then, of course, my standard deviation is the square root of this monster here. Hey, at least we don't have to substitute in, though. That, things could be worse. Okay, so that's what that would look like right there. Awesome. Okay, I'm gonna do some more examples in separate videos so you don't get overwhelmed with the length of this one.